Okay, now we're dealing with radicals of mixed index. And here's the radical we have to simplify. But before we do that, let's explore a nice simple way of dealing with this by dealing with a simpler radical. And so this equals, and we'll rewrite this in rational form. So we get a, and you know the ninth root, we'll write that as 1 over 9, a to the 1 over 9, and to the 6th power, we'll stick the 6 out here, and that equals a, when we multiply these two exponents together, we get 6 over 9. Now, 6 over 9 reduces 2, since 6 and 9 are both divisible by 3. That reduces to 2/3, because 3 goes into 6 twice and into 9 3 times. Now we can rewrite this in radical form. And 3 represents the root, so the cube root of, and 2 represents the power that's on a to the 2nd power. And now, the question is, when we simplify something of this form or this form, do we have to always convert to rational form and then evaluate and then go back to radical form? And the answer is no, we do not. No, we do not. What we can do is simply ask ourselves, is there a common factor between the root and the exponents on the basis under the radical? And if there is, we can divide through by that common factor, and the result will give us the radical form, the simplest radical form available. Notice, if you divide 9 by 3, you get 3. If you divide 6 by 3, you get 2, and we're done. So applying that, and we're going to keep doing things that way. Why? Because it's easier. And we've justified it right here. So this equals, and our first thing we have to do, let's see, we've got the 10th root of, and I'll write 64 in terms of its prime factorization, so that's going to be 2 to the 6th, and 8x to the 8th, and y to the 4th. And now we're always going to rewrite whatever given number we have in terms of its prime factorization in order to carry this out, you see. So now, notice 10, 6, 8, and 4 are all divisible by 2, so we'll divide each one of those values by 2, and 10 divided by 2 is 5, 6 divided by 2 is 3, 8 divided by 2 is 4, and 4 divided by 2 is 2, and we're done. That's as simple as it's going to get. There are no common factors relative to the values 5, 3, 4, and 2. So we're done. Okay, for the next mixed index radical, or set of radicals, we have the cube root of x squared and the 6th root of x to the 5th. Well, we want to combine these two. In order to do that, we have to rewrite them in terms of one radical, but before doing that, two radicals relative to the same root. And let's see, what is the least common multiple of 6 and 3? Well, it's 6. So what do we have to multiply 3 by to get a 6? Well, 2. If we're going to multiply this root by 2, we have to multiply that exponent by 2 also. And so we're going to have multiplying 3 by 2, we get the 6th root, and multiplying 2 by 2, we get x to the 4th. And now we have the 6th root here and x to the 5th. And notice, if we were to divide each of these values by 2, we'd be right back where we started from. So now, since we've got the 6th root, we can multiply. We can stick x to the 4th and x to the 5th all under one radical. And we get x to the 4 times x to the 5th. And that equals the 6th root of x to the 9th. And now, 6 and 3 have a common factor, which is 3, so we'll divide 6 by 3 is 2, and 9 divided by 3 is 3. Of course, we don't leave a 2 there because it's understood that without the anything here, that means the square root of, so we don't need the value 2 there. The value 2 is understood, and that's going to be x cubed, and we're done. Now for our third problem, we have to combine these two. Well, now, keep in mind that there's a 2 here, correct? This is a square root, so I'm going to install that 2, just so we don't forget. Now, what's the least common multiple of 2 and 5? Well, it's 10. In order to combine these two, we have to have them everything under one radical. And that radical will be the designated by the least common multiple of 2 and 5. So that's 10. So we're talking about the 10th. In fact, let's do them one at a time. Put a 10 here, and what you multiply 5 by to get a 10? 2. So then you have to multiply, and that's a 3 there. 3 times 2 is 6, and there's a 1 here, the exponent on b. b times 1 times 2 is 2, so let's do it again. We're talking that we know we need a 10 here, so 5 times 2 is 10. That means we have to multiply this exponent by 5 and this exponent by 5. Both of those exponents were 1. And now, by the way, I need an equal sign. Now we have everything's, this is the 10th root, this is the 10th root, so we can combine these and write everything under one radical, and we've got a to the 6 b squared times a to the 5th b to the 5th, and so that's going to be the 10th root of, and now we can add exponents, and the exponents on a are 6 and 5, so that's going to be a to the 6 and 5 are 11, and the exponents on b are 2 and 5, so we'll add those, and that's going to be b to the 7th. And notice this is the 10th root of a to the 11th is the same as a to the 10th times a. b to the 7th is just b to the 7th. Well, the 10th root of a to the 10th is a, so we got that out of there. And what remains under the radical? Well, we still have a factor of a, and the b to the 7th remains, and we're done.